Hi, my name is Abigail Clark, and this is my Physics Lab 5, Build Your Own Adventure, and I chose to do the following Slinky experiment. So today in this lab, we're going to predict and analyze what happens to the base of the Slinky as it's dropped from full extension. Does it stay stationary during the fall? Does it all fall at the same time? That's what we're going to see today. So some of the main physics law that we're going to see today is Newton's second law. And the properties of the force of gravity are also taken into account. And then below I've included the equations for Newton's second law, which are the final velocity equals the initial velocity plus net force over mass times delta t. And then the final position equals the initial position plus the average velocity times delta t. And today we're going to see that the initial velocity is 0 because it's at rest, and we also made the initial position 0 as well. And this is the experiment. I just want to show a little bit. As you can see, it falls, and then about here is where we're going to start it. You can see the tracker, and then all of a sudden it starts falling. And it falls to the ground, and then it kind of bounces back up a little bit, and then it falls back to the ground. But yeah, that's the experiment today. And this video is from YouTube. So for my results, you can see that that's why I skipped the first part of the video, because the position of the Slinky stays the same for the first part until the top of the Slinky hits the base, and then the momentum causes the Slinky to fall towards the ground and also bounce back up a little bit. As you can see, I included a scatter plot underneath, and you can see there's some gaps from the shots, like the frames in the tracker. They, a couple frames glitched out, so there's a couple gaps, but for the most part, you can see that once it gets to a certain point, the Slinky does start falling, and then it'll stay at the same spot, and then it'll fall a lot, and it comes back up a little bit, and all the above. So I also want to talk about some possible sources of error. For me, this time tracker was a little bit glitchy. I had some frames glitch out, like I said on the previous slide, so it caused some gaps in my data, which is unfortunate, but sometimes it happens. And also just tracking the object, like tracking in tracker with the point mass system was a little bit difficult because the video from YouTube became a little bit blurry, and then the axis was there, so that could have also caused some slight misconceptions of the data. And then the big question for today is what happened to the Slinky as it was dropped? That's the whole reason for this experiment. What happened to the base of the Slinky? Well, as you saw in the video, and I skipped to, the Slinky as it fell, the base stayed in the same place, but the momentum of the top of the Slinky as it came down and hit the base caused the base to go down to the floor and or fluctuate a little bit as it went down to the floor, but eventually it was at the floor. And so I think that this is because of Newton's second law and the momentum principle, because the energy and momentum are going to be conserved. And when the top of the slinky hits the base, it's kind of transferring that momentum to the bottom of the slinky and then hitting the ground because of the way the slinky's made, the hollow middle, and just the whole momentum there. And yeah, that's what I think happened to the Slinky, but in this experiment exactly. And yeah, thank you for watching my lab, and have a good day. It's the last one.